Hi everyone, today we are going to continue throughout chapter 4 with our exploration of numerical data and look at another way to graph numerical data, which is with box plots. Now, I know some of you may have seen this or may not have in middle school, and either way is okay because I'm going to explain it to you like you've never seen it before. So today you're going to learn how to sketch and draw a box plot, and then describe the distribution of a box plot and the important characteristics of it. So a box plot, or maybe referred to you in middle school if you ever did it as a box and whisker plot, summarizes a distribution displaying 5 key points. Okay, so this is called the 5-number summary. The 5-number summary consists of, the first number is your minimum value. The second number is quartile 1. Quartile 1 divides the lowest 25% from the upper 75%. The next number in the 5-number summary is the median. And the median, since we learned yesterday that that was the middle number, the median divides the lowest 50% from the upper 50%. The fourth number is what we call quartile 3. And maybe you can start to see the pattern here, you guys. Quartile 3 divides the lowest 75% from the upper 25%. And finally, our last number is our highest value in the data set, which is our maximum value. Okay? So, we're going to use our calculator to help us find this 5-number summary, similar to what we did yesterday to find the measures of center and measures of spread. So here, I would highlight this. It gives you the steps. Like I said, we did talk about this a little bit yesterday, but it's good if you highlight it. It'll be easy for you to find in your notes the steps to finding the 5-number summary. So the first thing we need to do is put our data in list 1. So in order to get to list 1, the first step is to go to Stat and then Edit. Now remember, we need to clear out those values in list 1. So I'm going to arrow to the top, hit clear, and arrow down, and that clears out list 1. Now go ahead and type in the values below. It does not matter which order you type them in, okay? So whether you read the rows across or up, down, it doesn't matter. Okay, now the next step, which again is the review from yesterday, so if this sounds familiar, it's good. Go to Stat, arrow over to Calc, and hit number 1, one variable stats. Some of your screens might not look like this. It might have like a list of 3 things. Just enter through that. Make sure, those of you that have the list, that it says list 1 since you put your data in list 1. The list numbers are in blue, as you can see here. They're in blue above the numerical value, so you would just use second and then that numerical value. So hit enter. Now there's this little down arrow key. We're going to scroll down, and there's your 5-number summary. Okay, so before we do that, I just want to explain one quick thing, which is about box plots, kind of just a little visual with the quartiles. So box plot is essentially divided into quarters. Okay, and that's an example of what a box plot could look like. Keeping in mind, this value right here is the minimum. This line right here is quartile 1. This line through the box, it does not have to be in the center of the box, and many times it's not in the center of the box. It's one way or the other. That line right there is the median. The line that closes off the box is quartile 3, and then that endpoint at the end is your maximum. Okay, and each piece, the lower whisker, okay, represents 25% of the data points. The lower part of the box is 25% of the data points. The upper part of the box is 25% of the data points, and the upper whisker is 25% of the data points. Now, some of the data is more spread out than others, therefore, that results in longer pieces of the box plot. Okay? So, let's sketch our box plot. I'm going to write out our 5-number summary over here. Our minimum is 637. Our quartile 1, so I'm getting these numbers off my calculator, is 702. Our median, 741. Quartile 3, 774.5. And our maximum is 855. Now, if these numbers are not the same as the numbers, if your numbers are not the same as the ones I got in my calculator, you could have just typed in one data point wrong, okay? Keep in mind, typing in one data entry wrong could throw off one number or multiple numbers in your 5-number summary. So just make sure to take your time when you're typing that data into your calculator. Okay, the first thing we need for a box plot is a number line. So I hope you enjoy the frozen ruler that my daughter let me borrow for this. Okay, now I know my minimum is 637 and my maximum is 855. So I am going to maybe start at 600 and just go by 50s. Nope, I don't think I need to go any further than that because my maximum is 855. Okay, but if I want to, that would be 950. Okay, so first thing I'm going to do, now the box plot is drawn slightly above the number line. So I'm going to look at my minimum and I'm going to put a dot, remember, above the number line at approximately where 637 is. And then I'm going to put a dot at 702. Trying to keep it along the same line if possible. 741. 774.5. So just about in the middle there. And 855. Now, in order to create my box plot, I am going to connect my minimum with my quartile 1 to make the lower whisker, my quartile 3 with my maximum to make the upper whisker, and then I'm going to draw my box using my quartiles with a line through the median. Okay, so something that all graphs should have, remember, is a title. So boxplots, you can put it down here along the number line if you'd like, because the number line, since there's only one scale, putting the title down here works too, or you can put it above it and just label the number line with its unit. But this is, I know it doesn't state it in the question, but this has got to be run totals using similar data that we did in the previous days for baseball teams. Like I said, I know it doesn't say it with the data, but we should always practice labeling when we can. So I just wanted to make sure we put that on there. Okay? So recall from the previous day's notes that the interquartile range is the distance between Q3 and Q1. And remember, it's a single number. You find the difference between the two. So find the IQR for the above data set. So remember, IQR equals Q3 minus Q1. So Q3, if I look above, was 774.5 minus Q1 was 702 for a difference of 72.5. Okay, and remember what we learned previously is that IQR describes the spread of the data set. So now, in our previous notes, we were kind of just eyeballing, hey, does this look like a potential outlier? Well, now we have rules for identifying outliers. So I highly recommend that you highlight this so you know where to go back to in your notes, because this will definitely be on your homework, your review, and the test. So there's two rules for identifying outliers. You need one rule, the top one, that identifies outliers in your lower direction, and another rule, the bottom one, that identifies outliers in the upper direction. So I'm going to kind of divide this into two. It says use the rules above to determine if the previous data set contains any outliers. So if I'm checking in my lower direction, and I'm going to rewrite the formula to help me remember it because I'll need to memorize this for the test. So lower direction, outliers would have to be less than Q1 minus 1.5 times the value of my IQR. So let me plug in the numbers that I have from the above data set. Q1 was 702 minus 1.5 times my IQR was 72.5. So I'm going to type that directly in my calculator as I see it. $702 minus 1.5 times 72.5, and that's 593.25. So, are there any outliers in the lower direction? Well, outliers would have to be less than 593.25. So I'm going to look right here. My minimum is 637, which is greater than this number. So are there any outliers in the lower direction? No. Because there are no numbers in our data set less than 593.25. Now let's look at the upper direction. In the upper direction, outliers would need to be greater than Q3 minus 1.5 times IQR. So they would need to be greater than, if I look above, my Q3 was 774.5 minus 1.5 times 72.5. Okay? So I'm going to type that in my calculator. Whoops, I'm sorry. I made a mistake. I just noticed it. This is not minus for the upper direction, it's plus. So make sure you're typing in plus. My bad, okay? Because we're going beyond the quartile 3. We want to see if there's an outlier in the upper direction. So beyond quartile 3. So we get 883.25. Okay, so numbers that would be outliers in the upper direction would need to be greater than 883.25. Well, let me go check what my maximum was in this data set. My maximum was 855. So are there any numbers greater than 883.25? Nope. So there are no outliers in the upper direction as well. Okay. So since there are no numbers beyond these 2 points, so less than 593.25 or greater than 883.25, we have no outliers in our data set. Now it is important to identify the outliers in our data set before we actually draw the box plot, and that's what we're going to do with our next example. Because if there's an outlier in our data set, it's going to change how we draw the box plot slightly. Okay, so let's do this next one together. It says, using Chris Johnson's 16 rushing attempts from his game on September 20th, 2009, calculate the 5-number summary and determine if there are any outliers that exist, make a box plot, and describe the distribution. Okay, so I'm going to type this data into my calculator. Again, in order to get to your list, you go to Stat, Edit, arrow to the top, hit Clear, and arrow down, and go ahead and type in your numbers. Notice this data set does have negative numbers. In football, if this is a running back, if they're pushed backwards rather than going forward down the field, that results into negative yards. So let's go ahead and get our 5-number summary. Going to Stat, arrow over to Calc, and number 1. So I'm going to scroll down. And I'm going to write my 5-number summary just above letter A. So my minimum is -3. My quartile 1 is 0. My median is 4. Quartile 3 is 8.5. And my maximum is 91. So, do any outliers exist? So let's go check those 2 formulas that we just learned. So in the lower direction, outliers would need to be less than Q1 minus 1.5 times IQR. And in the upper direction, they would need to be greater than Q3 plus 1.5 times IQR. Okay, so let's check the lower direction first. My Q1, whoops, I'm sorry. My Q1 was 0 minus 1.5 times, now what's my IQR? Remember, IQR is Q3 minus Q1. So what's Q3? 8.5 minus Q1 is 0, so my IQR is 8.5. So numbers would need to be less than whatever 0 minus 1.5 times 8.5 is. So outliers would need to be less than negative 12.75. Well, let's take a look. Negative 12.75, well, my minimum is negative 3. So are there any numbers less than negative 12.75? Nope. So there's no outliers in the lower direction. Now let's check the upper direction. Greater than Q3, which was 8.5, plus 1.5 times my IQR, which we found was 8.5. So I'm going to type that into my calculator, exactly how I see it, 8.5 plus 1.5 times 8.5. And I get 21.25. So, are there any numbers greater than 21.25? Well, I notice my maximum is 91. So yes, there are outliers here. There's actually two, 57 and 91. Okay. So now we got to take that into account when we make our box plot. So remember, the first step in making your box plot is draw your number line. And my minimum here is negative 3, my highest is 91, so I'm just going to go by tens, I think, starting with negative 10. Now I am going to I'm going to mark the first 4 numbers in the 5-number summary. So everything except the maximum for right now. So I have negative 3, then I have 0, then I have 4, and 8.5. Okay, so I'm just going to go ahead and connect my minimum and quartile 1 to make my lower whisker and make my box. Okay. Now, your outliers will need to be marked separately. So my outliers were 57 and 91. So my outliers need to be marked separately because they're unusual values. They're unique. They can affect, they can definitely are going to affect our range and our mean here for sure because they're so extreme. Now, my upper whisker is going to go to my highest non-outlier value. So take a look in the data set. What number is your highest non-outlier value? Well, these are both outliers. So my highest non-outlier value would be the 16. So that's where you're going to draw your upper whisker to in your box plot. Okay, if you need to, you do not have to write this on your homework review or test, but if you're trying to make a note, this was my highest non-outlier value. If we were to have an outlier in the lower direction, that would go to our lowest non-outlier value. So the lower whisker would be drawn to the lowest non-outlier value. Okay? And you'll always have a data set when you're making box plots whenever you're asked to make one, so you'll be able to identify what those values are. Okay, the last thing we need is a title. I'll just put it right down here. This was Chris Johnson rushing attempts in 2009, or on September 20th, 2009. If you want to add, I know some of you know that rushing attempts are measured in yards. You could, but that wasn't listed here, so you wouldn't have to. Okay? So there's our box plot. Now our last step is to describe the distribution. I wrote you a little hint there. Don't forget your socks. So remember, complete sentences when we're doing this. So the first S stands for shape. Ooh, shape of a box plot. We haven't really talked about this too much yet. So the shape of a box plot, we're only going to use skewed left, skewed right, and approximately symmetric for identifying shapes of a box plot. Also, when you're looking at the shape of a box plot, it's okay to ignore the outliers, and mention that when you're kind of describing the shape in your sentence. So remember, we're just going to focus on skewed left, skewed right, or approximately symmetric. So let me take a look here. Okay, I'm going to look. If the length of my box plot from quartile 1 to the median is approximately the same as the median to the upper whisker, then it's approximately symmetric. However, if the left side is more stretched out, or in other words, if there's a higher distance between your median and your minimum, then it would be skewed left because your left side's more stretched out. It would be skewed right if your right side is more stretched out. Okay? So there's a couple, I'd actually take a couple of them here because it's a little tricky. But so my distance here actually is from like -3 to my median is 4. So that has a distance of 7. But from here to this highest non-outlier value, that would be from 4 to 16. That has a distance of 12. So the right side is actually a little bit more stretched out. So you could say this is slightly skewed right. Now, if you saw it as approximately symmetric, because this upper whisker is more spread out, however, the lower part of the box is a little bit more spread out, that's fine too. Okay? But remember, it's all about comparing the lower half of the box to the upper half of the box. The lower half is more stretched out, skewed left. The upper half of the box plot is more stretched out, skewed right. If they're approximately the same, approximately symmetric. So the distribution is slightly skewed right, and remember, that's even with ignoring the outliers, because the outliers can affect so many things, and you don't need to write that. I'm just making note of that. If you want to, go ahead, especially for your notes. The outliers can affect so many things, okay? So a lot of times, sometimes we're just like, you know what, let's just look at it without them. Slightly skewed right, and the O in socks, remember, stands for outliers. With outliers at 57 and 91. Now, the last is C stands for center and S stands for spread. We have our center, we already calculated that. That's right up here. That's our median. And one measure of spread that we've already calculated is our IQR, which was 8.5. But keep in mind, you can also go back to your calculator and look at what the mean was. That's the X with the bar at the top. Or you could subtract your max minus min to also find your range. Either one is fine. But in your description, you need to tell me which statistics you are using. So the distribution center, so the distribution center can be described using the median of 4 and the spread with the IQR of 8.5. Okay, so that kind of puts together everything we've learned yesterday about describing distributions, making a box plot, and identifying the outliers, which were the 2 new topics we covered today. Keep your notes out, especially for those outlier formulas when you're doing your homework, and good luck tonight.